Welcome to this lesson. This is the part 2. I will do the second video on the prediction on chemistry paper 3. So take it serious and try to follow step by step. Remember to share and like. Share and like. Welcome. You are provided with solution M. So we have solution M, hydrochloric acid. Solution G containing 7.8 grams per dm cube. In the first series I said, whenever you are given per dm cube, you should know this is the same as 7.8 grams per liter. So it is the same as 7.8 grams per dm cube. So 1 dm cube is equal to 1 liter and is equal to 1000 centimeters cube. So this is one thing. You need to understand that. Then we are given this solid C. Procedure 1. I told you that paper 3 is about the procedure. Understanding the procedure. Fill the purate with sodium hydroxide solution G. Pipette 25 of hydrochloric acid solution M into the conical flask. So you understand that it is sodium hydroxide solution G reacting with hydrochloric acid. It is very important for you to understand that. So that is okay. So the next procedure, this is the volume. So what is in the purate? What is in the conical flask? You need to understand that. So in the purate, we have sodium hydroxide. So the volume we are going to have in the table is the volume for sodium hydroxide. That understanding is important, right? So the 25 that we pipetted 25, that is HCl. So we have 25 HCl, and the volume you are going to get from your experiment is the volume of HCl. In my table, I have the volume. I've always told you initial use 0.0, 0.0, 0.0, and this is my volume. So let's get the average volume. Since this is plus or minus 0.2. So when you look at this one, the difference from here up to here is very big. So we are not going to include this in the average, right? So we are going to do the average with the two values, 37.8 plus 37.9, and then divide by 2, because this one is outside. So this one will give us 37.65 centimeters cube. Determine the concentration of solution G in moles per liter. So solution G, you go back to the procedure and what you are provided with. So when you go here, so we want to calculate the morality. Concentration of solution G in moles per liter. Moles per liter means morality. Morality is the number of moles in a liter. So whenever you are asked the concentration of solution in moles per liter, always that one is morality. So this is the same as morality. So how do you calculate morality? I'm going to give you the formula. So morality, here we have mass in grams per liter. Grams per liter, the same as grams per decimeter cube. Then RFM. So once you have this one, then you know that morality now, you hold morality here is equal to mass in grams per liter over FM. Mass in grams per liter or per dm cube, whichever, per dm cube over RFM. Now solution G is sodium hydroxide. So we are going to get the RFM of sodium hydroxide. So RFM of sodium hydroxide. We have been given here sodium is 23 or that. So that is 23 plus 16 plus 1, and the answer is 40. Therefore, now we apply the formula. The mass in grams per liter we were given of solution is G. So you refer back to solution G, 7.8 grams per dm cube. So you come here and write 7.8 divided by 40, and you get the answer. You use your calculator, you get the answer as 0.195. Capital M stands for molarity. There is another way you can do it, though it is a long cut. This one is a shortcut. But for those who want long cuts, for those who understand what they are doing also, they can say if 7.8 grams, or 7.8 grams is contained in 1,000 centimeters cube, what will be contained in the volume we used here, solution G, the volume used here, that's 7.65. That is 7.65 centimeters cube will contain which mass? So that is 37.65 times 7.8 divided by 1,000, and that one will give you 0.929,367. That is the mass in this volume, right? Now the next thing, we will get the moles. So using the rectangle, the basic rectangle for moles, mass, RFM. So we have mass, so moles of G used will be equal to mass, which is 0.29367 divided by the RFM, which is 40. And that one will give you the number of moles, which is 0.00734,175 moles. But the question was asking us moles in a liter. Moles in a liter. So moles in a liter, therefore, this is the number of moles in this. So you will say 37.65 centimeters cube contain 0.00734,175. What about 1,000 centimeters cube? I told you this one is a long cut. It needs somebody who have understood the mole. Therefore, when you multiply this, the answer is going to be the same, 0.195 capital M. Now let's move to the next one. Now, Roman 2, calculate, the question begins here, determine the concentration of solution M in moles per liter. Remember, solution M reacted with solution G. We know the volumes of both solutions. So what we don't know is the concentration of solution M. So we need to get the moles of the, so solution G, remember G is equal to sodium hydroxide. So sodium hydroxide reacted with HCl. And the reaction goes like this. So this is the reaction. You can see the ratio is 1 to 1. Therefore, we know the volume of sodium hydroxide. It is 37.65. We know the volume of this, it is 25. So what else? We know the concentration of this, which is 0.195 capital M. So this is where we begin. We begin with those that we have, it's the one with its concentration. So we know that this is the number of moles in a liter. So we say 0.195 is the number of moles of solution G in 1,000 centimeters cube. So what about 37.65? Will contain how many moles? That's 7.65 times 0.195 divided by 1,000. So this gives you the number of moles of sodium hydroxide used, and that is now, since the mole ratio since the mole ratio is 1 to 1, it means the number of moles of sodium hydroxide is equal to the number of moles of HCl used. So meaning moles of 25 centimeters cube solution M is equal to 0.00734,175 because the mole ratio is 1 to 1. So we will ask 1,000 centimeters cube will contain how much? 1,000 times 0.00734,175 divided by 25. And that gives us 0.294 capital M. So that is the concentration of solution M. Procedure two, using a measuring cylinder, measure out 100 centimeters cube of solution M into a 250 centimeters cube beaker. Add oral solid Q, add oral solid C into the beaker containing solution M. Solution M, it is hydrochloric acid. Solution M is hydrochloric acid. Transfer all the solution into a 250 ml volumetric flask and top up to the mark using distilled water. Label this solution solution D. Fill tabulate with sodium hydroxide solution G, pipette 25 of solution D. Procedure two, using a measuring cylinder, measure out 100 centimeters cube of solution M into a 250 centimeters cube beaker. Add oral solid Q, add oral solid C into the beaker containing solution M. Solution M, it is hydrochloric acid. Solution M is hydrochloric acid. Transfer all the solution into a 250 ml volumetric flask and top up to the mark using distilled water. Label this solution solution D. Fill tabulate with sodium hydroxide solution G, pipette 25 of solution D. Into a conical flask, add this phenolphthalein indicator, then titrate. So this is the table I have here, but I want you to understand what is happening in the procedure because I've always told you the procedure is the chemistry, the practical we are talking about. Now we are adding solid C into a 200 beaker, then it is going to react with 100 centimeter solution of HCl, right? This solid will first react with this 100 centimeters cube. So it means it will consume some moles, but some moles will remain in 100 centimeters cube. So the solid will react with 100 centimeters cube, leaving some moles inside, but some moles will be used up. So remember that. Then now we are topping up into 200 volumetric. Now when we dilute this solution, the remaining solution, into a 250, so you need to know that the number of moles that remained after reacting with solid C the number of moles that remained in 100 centimeters cube of solution M, the number of moles that remained after reacting with solid C would be equal to the number of moles in 250 centimeters cube solution D. Did you hear that? The number of moles that remains after reacting with solid C is equal to the number of moles in 250 centimeters cube solution that we are going to prepare inside here. That is the critical thing that you need to master. But find the average is simple. Now this one, you look at your value, they are okay, so you just need to do your average. I've said you just write to 2 decimal places. It does not harm, it does not fight. It does not fight, just write 2 decimal places. Next question is calculate the number of moles of hydrochloric acid. Calculate the number of moles of hydrochloric acid solution in 25 centimeters cube solution D. So solution D is HCl but diluted as reacted with solution solution G that we know. So we have several more information of solution G, but D, we don't know much about it. But we know that this D has reacted with G. It is D which has reacted with G, but we know G. So G is the sodium hydroxide, and we know the molarity of sodium hydroxide. So we know that 0.195, it is the molarity of sodium hydroxide solution G. So this means these are the number of moles in 1000 centimeters cube. So we will find out the volume that was used. Sodium hydroxide is the solution that was in the purate. Therefore, the volume here is for sodium hydroxide. We will find out the number that is 11.7 centimeters cube will contain how many moles? 11.7 times 0.195 divided by 1000. Now that gives us the number of moles, which is 0.0022815. So you realize that molarity, you write in 3 decimal places, but the number of moles you can write as many decimal places as possible for accuracy. So moles. But we know the ratio. When sodium hydroxide is reacting with HCl, the ratio is 1:1. So since mole ratio is 1:1, then it means that moles of 25 centimeters cube solution D that reacted with G, 11 centimeters cube of G is equal to this one, is the same, 0.0022815, because the ratio is 1:1. The number of moles of hydrochloric acid in 250 centimeters cube solution D. Do you know the reason why we are asking you to find a 250 solution D? You will know why. So this is simple. Now we have moles. We have the moles in 25D. So we will get into 50. That one is very simple. So we will say 25 centimeters cube of D contains 0.0022815 moles. We will simply ask 250 centimeters cube of solution D will contain how many? Is 250 times 0.0022815. We divide by 25, and this one gives us 0.02215 moles. So this is the number of moles in 250. Now the next question is calculate the number of moles, determine the number of moles of hydrochloric acid in 100 centimeters cube of original hydrochloric acid. Solution M, original. So original, remember, you need to refer back. We did the morality of solution M, original. So we had the morality. Morality is 0.294. And remember, morality is the number of moles in 1,000. So we have the morality of solution M. We have the morality. So you come here, we know that the morality, you don't need to, I'm writing this for your own good, so you don't need to write this when you understand. So the morality of M, we know it was 0.294, capital M. So this is the number of moles in a liter. So we will ask that 1,000 centimeters cube of solution M contains 0.294 moles. So we will find out 100 centimeters cube will contain how many? So 100 times 0.294, we divide by 1,000, and we get our number of moles in the original 100 was 0.0294 moles. So this is the number of moles in 100 centimeters cube of the original that used. So when we added solid C, was it solid C? So the moment, so this solution that we put solid C inside, this is 100. This one, number of moles here initially was this one. So after reacting, the number of moles that reacted, that after the reaction, the number of moles that remained is the one that is in 250. So this is the number of moles that remained after reacting. This is the number of moles that remained. It is calculate the number of moles of hydrochloric acid that were used up in the reaction. Very good. That were used up, that reacted with the number of HCl that reacted with this. Right? I have told you for understanding, for clarification, let me repeat that after 100 centimeters cube solution M reacting with a solid, the 100 centimeters cube remained. The solution remained ikiwa 100. Sawa, sasa ilikuwa 200, hakuna kitu ilifanyika, haikuisha. But what happened is the number of moles decreased because initially ilikuwa na moles and react na solid, so the number of moles decreased. So the moles that remained 100 centimeters ile maji ilibaki wakaongeza hadi ikafika 250. So it means the number of moles that remained in 100 is equal to the number of moles in 250. So that is the thing I want you to know. Therefore, to get the number of moles that reacted with the number of moles of HCl that reacted with solid C, it is simply the number of moles of the original and minus the number of moles in 250 centimeters cube solution D. Very important. That is what you need to understand. That's what you need to understand. Okay, so let's now, the answer here is going to be 0.0294 minus this answer, number of moles minus this one. 0.022815. Now that one gives us 0.00685 moles of HCl. This is the number of moles that reacted with solid C. This is the number of moles of HCl that reacted with solid C. Very good. Because we have subtracted original minus number of moles that remained, so it has given us this. Please understand that. Number of moles, calculate the number of moles of the carbonate that reacted with hydrochloric acid. You need to understand that when a carbonate is reacting with hydrochloric acid, the ratio, mole ratio. So you need to know that. So let me write for you when we have, let me write for you the ionic equation first. We have not been told, but it is important you know. So hydrogen ions in HCl will react with the carbonate in the carbonate ions in the carbonate to form water and CO2. So this water you see has 2 hydrogen, therefore we need to put 2 here. So this means that the ratio is 2 to 1. The hydrogen ions is twice, carbonate is 1. But we have the number of moles of hydrochloric acid to be what? To be 2. Therefore the moles, because of the ratio 2 to 1, the carbonate is going to have a half of the moles, a half of the number of moles. Therefore moles of C, that is the carbonate, is equal to a half that of the acid, which is 0.006585. And that one gives us 0.0032925 moles. This is the number of moles of the carbonate. Very important. This is the number of moles of C, the carbonate C. Given that the relative formula mass of carbonate C is 106, calculated the mass of the carbonate that reacted. So RFM, we have been given the RFM. So how do you get the mass? You can use this formula. You remember this triangle? I have told you we have 3 triangles that are very important. We have this one, the basic one, moles, mass, RFM. RFM is the same as molar mass. Molar mass. So we know if we want mass, how do you get mass? Mass is equal to moles times RFM. So we have the mass of the C that reacted, which is 0. We have the moles, 0.0322925 times the RFM molar mass, which is 106. And that one is going to give us 0.349005 grams. So this is the mass that out of the original mass, which was 0.5, this is the mass that has reacted. Therefore, we want to check the purity. So this was the pure one. So the other remaining is impure. Therefore, how the purity, percentage purity, it is this mass, 0.349005 divided by the original, then you multiply with 100. And this one gives us 69.8%. That is the percentage purity. Let me now take you through of this. I want to take you the 1998 chemistry practical. Let me take you through the qualitative. I did the quantitative part of it. If you have not seen the video, the link is in the description. The description ni hapa chini. Hapa mahali unaangalia hapa hivi chini kwa hiyo YouTube hapo, ukiangalia hapa chini ndio inaitwa description hapa. Kuna link hapo utapata hii video. So let me take you through this one. Thank you for enjoying the lesson. Share, like, and comment. But I wonder some people, you are too mean. Unakaa kama wale ni wachoyo because hawataki maendeleo. So you cannot I am now teaching you until it is midnight. It is midnight. Lakini uwezi unakataa kushare, unakataa hata kusay thank you. Mshindwe kabisa. You have been provided with solid S. Carry out the test and record the observations and inference in the space provided. Place about 1/3 of solid S in a dry test tube. Heat gently and then strongly. Test any gas produced with red and blue litmus paper. So I will give you the expected observation and then the expected inference. So whenever you are asked to test for the gases, you need to tell us the color change. And the first thing, anytime you are heating a solid. Ensure the test tube is dry so that you can see the droplets of, the first thing we expect is the droplets of a colorless liquid. Don't try the water. We don't auto use this water. So it should be droplets of a colorless liquid is formed at the cooler parts of the test tube. Yes, whenever you are heating a solid, make sure that the test tube is dry because you need to observe at the mouth of the test tube whether there is droplets of a colorless liquid. Don't write anything else. It is a colorless liquid because you don't know. Of course, you see it is water droplets. Don't write water. It is a colorless liquid is formed at the cooler parts of the, or at the mouth. You can say at the mouth of the test tube. Therefore, if that happens, then it means solid S. Solid S is hydrated. You can also say it contains water of crystallization. Now we are testing. How do you test for the color? You dip the blue litmus paper and the red litmus paper in distilled water. Then you put it on the mouth of the test tube before you start heating. So now you heat and then you observe the color change. So if red litmus paper remains red, it means the gases that was produced is acidic. So now like this one, red litmus paper remains red. If it remains red, it means the environment is acidic, so it cannot change the red to blue. While blue litmus paper, red remains, oh no, this was wrong. Now red litmus paper remains red, and the blue litmus paper changes to red. It means the environment, the gas that was produced was acidic. That's why it is changing the blue litmus paper to red. Because the environment was acidic, that's why red litmus paper remains red. Therefore, you say acidic gas produced. Or if you don't write this one, when I say or, or, just write either this or the one I'm giving, or hydrogen ions present. So you choose one to use, either acidic gas is present or hydrogen ions present, either. So what if now the red litmus paper changes to blue and the blue remains blue? If red changes to blue, it means the environment is basic. So if it changes to blue, please make sure you write. If the red litmus paper changes to blue, then it means ammonium ion is present. Ammonium ion stands for alkaline gas produced, alkaline gas or basic gas produced. You can use either. It is either you use this one or you say basic gas produced. If the red litmus paper changes to blue and the blue remains blue, it means alkaline gas or basic gas or ammonium ion present. Dissolve the remaining and then to the first portion add sodium hydroxide. We are adding sodium hydroxide as our first reagent. Then it means the observation is a white precipitate is formed and that white precipitate dissolves to form a colorless solution. So if it dissolves, the white precipitate dissolves, then it means that the ZAP is present. The ZAP is present. ZAP means zinc 2 ions, aluminium 3 ions, and lead 2 ions present. Remember, do not write it this way. Do not write this way. Can you write chemical symbols the way they are supposed to be written? Otherwise, you will get nothing. So these ones are present. Because you know this one are amphoteric, they will react with sodium hydroxide, and in this case, they will behave as acids. Now, to the second portion, add ammonia. Remember, ammonia is used to confirm for zinc. If the white precipitate is formed soluble in excess, which dissolves in excess, then it is zinc present. Zinc is still present, zinc 2 ions. But this one is a white PPT formed and it does not dissolve in excess. It means zinc is absent. And if zinc is absent, and in the first one we had 3 of them, it means zinc is absent, then what is present? It is aluminum and lead. So you don't write what is absent, you write what is present. Therefore, if zinc is absent, then it means aluminum 3 and lead 2 are present. That is what it means. Don't write zinc positive absent. To the third portion, add 10 centimeters of barium chloride solution. So there is no white PPT. So barium is used to test for the 3 cations, that is the carbonate, the sulfate, and the sulfite. So if there is no white PPT, then it means the sulfite, the sulfite, and the carbonate are absent. To the fourth portion, add 1 centimeters of lead to nitrate solution. Then a white PPT is formed. So lead forms a white precipitate with sulfate, sulfite, carbonate, and chloride, even bromide. But now, so I'm saying, let me repeat what I'm explaining here, slowly by slowly, because you need to understand. Lead, if a white PPT is formed, it means lead it contains, so if lead meets with the sulfate, it will form a white precipitate. If it meets with the carbonate, it forms a white precipitate. If it meets the sulfite, it forms a, if it meets the chloride, even if it meets the iodide or the bromide, it will form the bromide, yes, it will form a white precipitate. But now this one is not common, we stop about chlorine. Now, if this one forms the white precipitate with lead, and this one are absent from the first three, do you think that if you write them here, you get a 0 because you are contradicting? Therefore, it means it is chloride ions which is present here. That is the understanding I want you to have. So this is KCSE 1998, as I showed you. So I'm revising with you as you prepare. Remember to share. Wacha kwa watu wengine ni wachoyo ile ya uchawi. They don't want even to share, they don't want to like, I spend time teaching you, but you cannot even like. Shindwe.